In this problem, we are told that there are 4 classes, an arithmetic average of 17 students per class, which is just a fancy way of saying there is an average of 17, each have $4.40 to spend. We know beyond that 1/8 of those students buy cupcakes, and they buy 2 boxes of 11 cupcakes each. So, stepping back, the approach we'll want to take is figuring out the total dollars spent on cupcakes divided by the total number of cupcakes should give us the answer to the question asked, which is the cost per cupcake. So let's begin that calculation. 4 classes times 17 students per class. And recall, it doesn't matter that it's an exactly 17 or an average of 17 per class, because the total is going to be the same, and that's what we really need to calculate. Times $4.40 per student to be spent. So that's the total dollars to be spent. And I'm going to make one comment here. I am not going to make the calculations here. I'm not going to calculate what 4 times 17 times $4.40 actually is in the number, because it will be easier for us to reduce and simplify the fraction after we've laid out all the figures. So if this is the total dollars spent here, we need to multiply by 1/8 for the amount of money spent on cupcakes. So this is, in total now, the amount of money spent on cupcakes. We would need to divide that amount of money by the exact number of cupcakes purchased, which is going to be 2 boxes times 11 cupcakes per box. We can begin to simplify, and let's take a look at that. I know the 4 times 1/8 really becomes 1/2. 17 is a prime, that can't be reduced. 440 we could actually restate as 4 times 10 cents times 11. Now, oddly enough, most people will make a calculation to get the products as they go along. I'm actually doing the reverse and breaking out the number into some of its factors to make it easier to reduce the fraction. In this case, 11 cancels on the numerator and denominator. Our 4 that's left, we know will reduce with the 2's. So let's restate this for a second. We now have 17 times 4 times 10 cents divided by, and I'll put the 1/2 because multiplying by 1/2 is also the same as dividing by 2. 2 times 2, or 4 on the bottom, at which point we can cancel the 4 on numerator and denominator. And our final result is just 17 times 10 cents, or $1.70. Note, we quickly arrived at our final result without making a difficult multiplication or long division calculation. And the reason that was possible is because we did not do calculations iteratively as we went through the problem. 4 times 17 times 440 divided by 2 divided by 11, kept the figures separated as is, and even factored some of the numbers like $4.40 further, so we could simplify the fractions and get to a result more quickly. And that's the real key to solving this problem more quickly. So remember, it doesn't always pay to rush into calculations. Lay out and organize your problem first. On to problem 2. Oh my goodness. What do I do with 53 degrees and all these numbers on the triangle within the circle? Well, like many problems that you don't recognize at first, go back to fundamentals. What do we know about triangles and potentially circles as well, or something about the circles that will help us solve for the triangle we need to find? Essentially, what the question asks is, if I have triangle A, B, C, all along the circumference of the circle with center point D, what is the area of A, B, C? Well, again, going back to fundamentals of triangles, what do we know? Do we know anything about 53 degrees that helps us solve for the area, or perhaps the lengths that could get us the area for the triangle? Not really. I think that might be extraneous information. So let's ignore it for the moment and move on. What do we know about this triangle? Well, we know about Pythagorean theorem that a right triangle, the square of the 2 sides, sum to the square of the hypotenuse. I don't have the length of the 2 sides. I have one side, 6 meters. I don't have this side or the hypotenuse yet, so that doesn't help me. I know a 3, 4, 5 triangle is a special case of that Pythagorean theorem. I don't see 3 4s in here, although I do see 5 meters. Let's see. I know the inequality theorem. One side length cannot equal the other two side lengths. I'm not sure how that helps me here in fundamentals. I know the interior angles of a triangle must sum to 180. I'm not sure the 53 helps us out in that regard. So, with all that, what do we know? What information can we deduce to make this look like something that helps us with our fundamental knowledge base of triangles? Well, we know the radius is 5 meters, dB, and that radius is true all the way around. This radius is 5 meters, and this radius is 5 meters, and likewise this radius is 5 meters. So we actually do know some information that's not provided directly in the figure. We know the diameter, which is 2 radius lengths, or radii lengths, is 5 plus 5 equals 10 meters. So we have a diameter of 10 meters. And if our diameter of 10 meters, we now have a hypotenuse of a triangle that looks like it's 10 meters, and one end length here that looks like it's 6 meters. Does that help us? Well, yes. In Pythagorean's theorem, I can call this side length x, and we can solve for x, assuming I had a right triangle. Wow, there's the tough part. But wait a second. I think we must have a right triangle, because this looks a good deal like a special 3, 4, 5 triangle, which we know is a right triangle with hypotenuse 5 and side lengths 4. In this case, we have 10 for hypotenuse. We have a side of 6. Well, that means our missing side must be 8. And that is, of course, in the same proportions, double of each of the numbers of a 3, 4, 5 triangle. It's 6, 8, 10 triangle. So x must be 8. That helps us solve the problem right there, recognizing the fundamental 3, 4, 5 triangle. We now know the angle shown here must be a right angle, and therefore it's 90 degrees, and we can multiply the base of 6 times the height of 8 meters, which are perpendicular, to arrive at the area of the triangle. And in this case, it's 1/2 base of 6 meters times height of 8 meters equals 1/2 of 6 times 8 is 48. 1/2 of 48 is 24 square meters. And that is the answer to our question. And importantly, we had to have enough confidence to take something that was not recognizable at first to us, explore our fundamentals, what we know about triangles, and likewise ignore extraneous information provided in the problem. I hope that helped. And I hope it provides a good framework for approaching problems you don't recognize.